Start. Good morning.
Morning.
We will continue our discussion on C++ programming. And last time we are almost done with, I think, chapter 9, functions. See here. Okay. One thing about functions is that before you call a function, it needs to be defined first. And for C++, you kind of imagine when the program is executed, there is always a current execution point. The execution point starts from the very beginning, the first line of the program, and move down unless there is a conditional statement that you will go according to the condition, right? Well, as far as the functions are concerned, if the main function is the first function in that main function, a user-defined function is called, then there is a problem. Because at that point, the user-defined function is not defined yet, because you put the main function first. For that reason, if you want to call a user-defined function in the main function, that function needs to be defined before the main function. That kind of reduces the readability of the program a little bit. Okay, so how to resolve this issue? Well, C++ provide a means to resolve the issue. It's called, you can define a prototype of the function at the beginning. It just tells the program a function name, a certain function name is going to be defined as a function. But the details of the function will be left later in your definition. Okay? All right, let's say an example that we use integer addition and we define a and then integer b, and then you can simply say return a plus b. So this is a very concise definition of the user-defined function addition. And then here is your main function. And then you're going to do something, and then you call this function addition, provide a value of 5 here, a 3 there, and then you're going to something else. So that is fine, because the user-defined function addition is before the main function. When the compiler compiles the program, it should be fine. At that point, the function is already defined. Okay. However, most programs are good for readability reason. The main function usually comes first. Okay. So to resolve this issue, we can now use function prototype. Okay. So instead of really define the function at the beginning, you can say integer addition and then integer a, integer b, right? And you may have other functions. You may have integer multiplication, for example, multiply, let's just say mult. Okay. That amount will be x integer y, and things like that. So you can have a long list of function prototypes, okay, immediately after the derivatives. And then here you can have your main function, and inside the usual body of the main function. And there you may call addition and do something, and then call the mult function and do something. So that will be fine. And then here you will have then define the addition usual function, integer a, integer b, and then return a plus b, and then similarly define the mult function. Okay, so this way of defining functions are called using the function prototypes. The prototypes will inform the compiler to prepare for memory space for a function. Because it is defined here, the compiler will know a function called addition will be defined is of the integer type. It will take two variables, both integers, as is a function parameter. Okay. Because of that, you can even omit the function variables in the argument. Here, you can say integer a, comma integer b, but you don't have to really write this a and b there. These are just optional. Okay? So you can in the prototype definition you can say integer addition, which is function, and inside the parenthesis int, comma int. That's also fine. So you can totally leave out those because it serves no practical purposes here. As long as the compiler knows the first position is an integer type, that should be sufficient. Okay. Here you need it because inside the body you need to refer that variable, right? Otherwise, you don't establish the relations here. So this is needed because this and that is the same thing. All right, that's the function prototype. Okay, and then we're going to talk about next chapter, chapter 10. It's called name visibility. Okay, all the examples we use in the lecture are very short, simple examples. We may use 2 variables or 3 or up to 10 or 20. We're not going to use 2,000 variables in a classroom example, right? But if you look at any commercial code, even the FEM code we are going to do later for this class, it's likely that you use hundreds, if not thousands, of variables. When you run into hundreds or even thousands of variables, sometimes later in the program you may forget what the function names has been used before. Okay, like x, We always like to use x. Everybody loves x, okay? X and y, x plus y. But there's only one x, right? So the problem becomes, if in a user-defined function you use x, in the main function you also use x, and then in some namespace there may be x. How do you distinguish these local x from these main x and also the global x here? Here you can define a variable. These are the function prototype, but if you like, you can also define some variables here, integer x and double y, like that. Any variables declared outside any function bodies are called global variables. They can be used in any functions. Okay, these are global. Now, here I can also define a integer x. Here I may define a double x, which is perfectly okay. Now look at this program. I'd like to draw your attention to these three statements. I have one here, I have one here, I have one here. They all use the same variable named x, but they are three different x's. Okay, they live for different period of time and they serve different scope. These x only exist and is only known from this point up to that point, locally to the main function. Okay, this x is only known locally inside this function. Outside of that, you have no way to access that variable. Its value will no longer, can never be changed for any functions outside that. Okay, any statement outside that. This one, however, is global because it's declared outside of any functions. Therefore, if I have another function like print function, okay, void print function, and then here I just say out, like that, return. Oh no, there's no return. If I call this function, you see there's no functional variable definition here, but this is correct because why can I do that? This x has been defined globally. So any function can access that x. Alright, therefore the main point is that there is the concept of scopes, which refers to a period of time during the program execution. Okay, the scope, we can say there is the global scope, like those functions, these variables that are defined outside of any function that is global. It will come into existence once the program is started to execute. It will stay there until the end of until the termination of the program. Okay, because of that, we also call those storage static, which means it's there all the time. Okay, and then there's the local scope. Any function any variables defined inside a function is local only to that function. It's known only to that function. It's not known and cannot be changed outside of that function. Okay, so this kind of storage is called automatic. During the execution of the program, when a local variable, the function is not called yet, any local variable defined in the function, there's no need to assign memory space to it, right? Okay, it will only, the memory space is only needed when the function is called. Okay, once the function is called, and of course, you need to assign memory space for those guys to do something. At the end of the execution of the function, you return to the calling place. There's no need for those local variables to exist anymore, right? And they will be eliminated from the memory space, and the same memory space can be used for something else. Okay, that's just natural, right? For this reason, any local variables, their storage type is called automatic. Okay, it only exists when that function enters into execution. It will be deleted when the execution of the function is completed. Okay, all right. Because of that, there is the question in this example again, how to distinguish the global X, the local X here, and the local X there. Well, if here the priority or the precedence of a variable is this, when you have the same variables, the local variable always take precedence. Okay, so here when you call X, it will mean this X, not that one. And here when you use X, it will also mean this X, not that one. Okay, but there's something called namespace. A namespace is a definition or a preserved space that you can use to define a bunch of your variables. And for example, if you like, you can define two namespaces. One, you call it my K-state namespace, in which you put X, Y, Z. And then another one, you can define it in another namespace, you can call it Manhattan, which is the town name, right? So in Manhattan namespace, you can also define X, Y, and Z. So both namespaces have the same variable names. When you need to refer to that, you use an operator called scope operator, okay? Then to distinguish the different X's. All right. Let me give you an example. Okay, here, for example, okay, namespace KSU, and then here I define an integer X, a double Y, and even a string to store words, okay? This is one namespace. And then I can define another namespace. Let me call it MNE, okay? All right, and here I have a double X and a integer Y, and then another string Z, okay? All right, these two blocks of code, just to make it more, here I can put several, A, B, C also, that's also fine. So in one data type you can have more than one variables, like that. Then, once you define this namespace, if inside this program, let's say that this may, you want to refer to that X, what would you do? You do that. Okay, in order to refer to this X, you put the namespace first. That namespace is called KSU, okay? So now I have a print, I'll put that C out less than KSU column X. This is the namespace identifier, and this is the namespace operator, the scope operator. It simply means that X refers to the X defined in the namespace KSU. Okay? And then in the same way, you can output C out here. Now I want to print out the X in the MNE namespace. Fine. So less than, this time is MNE column X. You see, this scope name and scope operator, the namespace and the scope operators differentiate these two X's. So now you can define the same X in different namespaces. They can be used completely independent of each other. Okay? When you need to refer to that, you only need to put the identifier of namespace in the scope operator. So that's how to use that. Okay? Now, let's say in this part of the program, if in this part of the program, the KSUX will be used a lot. The MNEX only used once or twice. This is maybe 50 times for some reason. Keep writing that will be a little bit tedious, right? And then how do you resolve that? Then you can use, okay, let me erase that. You can use a useful word called using. KSU. Okay? Using namespace KSU. That will tell the program here in this function, without the KSU double column, any variables defined here will refer to that namespace. Okay? Therefore now my C out X will be this X. And then anywhere when X appears, it will refer to the KSU namespace. Okay? But occasionally you still need to refer to the MNEX, then you just put MNE double column X. Okay. And then this will distinguish this X from the KSUX. Okay? Therefore, this keyword is useful using namespace. Okay. Now, at that point, you will understand. Okay, let me close that. All right. So these X refers to these X. Now that X, of course, refers to that X. Okay. All right, now remember in our first program, we forgot to put a statement using namespace std, and then when we try to use cout, there's an error. That's the reason, because without referring to the namespace, cout is undefined. Okay. Therefore, Cout is one of the defined output streams in the standard STD namespace. So by using that, we don't have to do that. If we don't have to, okay, these two code, if we do not have that, every time you use Cout, you should write it as STD column Cout. So the program will know that Cout is the Cout defined in the namespace called STD. Okay? Of course, if you only use Cout once or twice, you may do it like that. It's more economic, right, to do that. But if you use Cout tens of times or hundreds of times, it will be much easier to put this statement here to save writing that many times. Okay? All right. So that explains first the name visibility. Okay, when you have same variable names, they can exist globally. Some can exist locally. Okay, you can also put variables in named named namespace. You can have different namespaces, and they have the same name, but as long as you put the namespace name, identifier, and the scope operator, they can be distinguished. Okay, I think that's it. So the key concept is know what is a global variable. Any global variable is storage type is always static, which means exist throughout the life of the program. Local variables, they only exist for the short period of time when the function is called. Okay, that storage type is called automatic. And by the way, when you declare a global variable, like this integer x, even though you have not initialized its value explicitly, all global variable will be explicitly initialized to have the value of 0. Okay, this one is different. Erase that. Any local variables like this one, if you declare it but do not initialize it, you can have undetermined variable. It's just whatever the computer happened to have as a value at that point, it will be that. So it's totally random. Okay, it is very dangerous to use a variable with random values. The results is just unpredictable. Okay. All right, that's actually chapter 10. Let's move on to chapter 11. Chapter 11 is introduce a very important or very useful concept called array. Okay. Arrays are a convenient way to manipulate data. For example, think of solving simultaneous equations, 100 simultaneous equations. So you have a coefficient matrix of 100 by 100. It is simply impossible to program that without using array. For any matrix, right? First, just the declaration or assignment of the 100 times 100 value could be pretty daunting. You want, right? But with arrays, you can use a loop statement to assign or initialize values quite easily. Okay, so for convenience sake, we may want to use arrays. For other cases, like inverting a matrix, it's a must to use arrays, okay? All right. What is an array? Array, when you declare array, you put a identifier first, you put a type, you put identifier, and then a square bracket and dimension, and then closing a square bracket. So this is the syntax for declaring an array. Example. If I say integer full square 5 closing square, like that, what will happen? Well, when the compiler encounters that statement, it's going to prepare a memory space and block out 5 consecutive memory space for that array full. The cell size of the memory space corresponds to the required length for the integer type. Okay. All right. Let's just draw it like that. 1, 2, 3, 4, 5. This array is labeled full, and then the index here will be 0, and then 1, 2, 3, 4, and the total number of elements is 5, right? Okay. And now kind of imagine this is the memory space. You can put any integers here. So that's what will happen. So an array is nothing but a series of numbers of the same data type stored consecutively in the memory space. And you can refer to or access to the value of those numbers by calling the identifier name and indicating the index here. For example, this one, when I declare it, I do not initialize it. Therefore, right now, all these 5 memory spaces, they may have undetermined value, okay, a random value. But if I do something like that, if I say equals and put into square bracket 2, 4, 6, 8, 10, like this, then what will happen? First, array of the identifier full is declared, its size is 5, and these 5 elements are initialized to the following value, 2, 4, 6, 8, 10. So I have this one value 2, this is 4, this is 6, 8, this is 10. Okay? Now, if I have a statement as follows, C out less than, and then full 1 plus full 3. Okay, for that statement, what will be the output on the screen? What is the value on the screen? 12? Why is 12, John?
Well, because foo1 is 4 and foo3 is 8.
Very good. Because this full one refers to that one, not the first one. Yeah. It is, you must remember, in C and C++, the index always runs from 0, not 1. That is a huge difference between the C and C++ and Fortran. And in Fortran, the first index is always 1. Okay? All right, so this refers to the second element of the array, which is 4, and this is 8. Okay. Therefore, now you can see this is the declaration, this is the referencing or assessing the element value. Therefore, you need to see this square bracket in different ways. It happens all the time. Okay, so what you see here, this is a declaration statement. It's not referring to the fifth element. No, it just means this is an array, its size is 5. Here, this tool is accessing individual elements, okay? And this says this is the second element of the array. This is the fourth element of the array. Take those values and add them together, okay? So these square brackets here have different meanings during declaration and also during execution, okay? Okay, that's array. You need to always remember that all the array elements will have the same data type. Okay, you cannot have an array. The first element is integer, the second is double. That's just not allowed.
Would it be better to define them as floats usually, or what would?
It depends on your need.
Yeah.
For example, if you want to count or manipulate the number of students, I think you prefer the integer type.
Right.
Okay, but for FEM, probably a lot of cases you want to use double, but still, number of nodes, number of elements, you want integers, right? Okay. All right, this is one way to initialize value. You can do it this way. You declare an integer of size 5, but only put 3 values here. What will happen? Will you get an error message during compilation?
I don't think so.
No, you are okay.
Just leaves a message.
What happens is, if you put this in the first place, this in the second, this in the third, the fourth and fifth will just be undetermined. Okay, it's not necessarily empty. So in that case, I will put a question mark here. Okay, just the random values there. Oh, I'm sorry. I just look at the lecture note. If you do that, the remaining element will be implicitly assigned to the value of 0. Okay, and that's just a convention for C. So when you initialize some front values, the rest will be initialized to 0. Now, if you put even nothing here, then all of these, as long as there is a curly bracket, you will understand you try to initialize something, so you will, but no values here, you will put all zeros here. And as you can see, this is convenient. Okay, sometimes you want to declare something, and you want like an array of size 200. It will be pretty tedious to write 200 zeros there, right? So you put an anti-curly brackets there, and you will initialize all 200 values to 0. And then, later, C++ even make it more concise, okay? They allows you to skip this equal sign here. Now you can do 2, 4, 6, 8, 10 without the equal sign, and the compiler will assume you intend to initialize this array to have these values. So you will put here 2, 4, 6, 8, 10. And again, if you skip some values at the end, these will be initialized to 0. Okay? So that is array declaration and initialization. Again, to access the value of an array, you put array name and put the index with inside a square bracket. Okay? All right. Next, this is the array, and then we have the same way we can declare multi-dimensional arrays. Let's say integer Jimmy 3 and then 5. This statement will declare a two-dimensional array Jimmy, and the column is, number of columns is 5 and number of rows is 3. Okay, therefore graphically it will be like this. The compiler will block that many memory cells. Okay, and this one, this is 5, this is 3, so it's a total of 15 memory cells, memory spaces. Now, to refer to each individual element, again, let's say this one, it will be Jimmy. You need 2 indexes. What should be the first one here? This will be the number of rows. Okay, so this is 0, 1, 2, so it will be 1. This one? Also 1. Okay. Similarly, these will be Jimmy 1 and then 0, 1, 2, 3. Okay, so that's how to access the individual element. Even though graphically we like to, okay, we can say this is 5 columns, this is 3 rows. We want to represent this graphically as a matrix. In reality, inside the computer program, actually it's just a 1D array. What happens is you will have one memory space and put this. This is next here, and this will follow that also. So because in computer implementation, memory is sequential. Okay, so everything is 1D. I would say for this course, we will use 1D array a lot. We will use 2D arrays sparingly, but we need it, like for matrix solving equations. I'm strongly against using more than 2D arrays. You can, in principle, you can define 3D array, 4D array, and things like that, but it becomes unnecessary, and sometimes it's confusing. Another practical reason is that multi-dimensional arrays consumes memory space very, very rapidly. Okay, so you want to be very careful about that. One important thing is using arrays as function parameters. Okay, for example, in FEM, of course, you will have to calculate stiffness matrix. Once the stiffness matrix are assembled, you have a global stiffness matrix, and you want to invert it to get displacement, right? Now you would like to write a function for matrix inversion. So you need to pass this global stiffness matrix into that function as a variable, so you can take the value and find the inversion and then return it back, so you can calculate next times the inversion of the stiffness matrix with the force the load vector, then you get displacement, right? Therefore, you need to use that a lot. Now, last lecture when we introduced the concept of functions, we said there are 2 ways to pass variables. One is called by value. A copy of the variable is made and passed into function. The other one is called call by reference, and then the variable itself is used in the function calculation. Okay, with arrays, it's always called by reference. There's a reason, because arrays are usually huge. Every time you want to make a copy of an array, that's kind of time-consuming and memory-consuming. Okay, therefore, arrays as function variable, function parameter is always called by reference. Okay. Now, let's say in the main function where an array is declared. Okay, this is the topic of array as function parameters or argument. Okay, let's say we define a double k f vector of 100. Okay, and then we define a void function print array double and then x okay. This is how you define a function that use an array as an argument. You put the array type and an identifier of the array and then a square bracket after that. That square bracket should be empty. It just tells the compiler that this x is an array, not a usual double integer. Why the square is empty, not 100 here? There's a reason. Actually, the array identifier itself is a pointer. Okay, with that, the function will know this is a pointer that points to array, or you can understand that as an array identifier. Okay, and during the functional call, okay, that's the definition. And then inside a main function, somewhere when you call the function, you do it this way: print array. Okay, if you do that, let's say the double f is declared as a size of 100 element. You declare that, and then we can also initialize it to 0. Okay, or some other name. The first one, let's do this. Let's say 246. If you do that, first 3 elements will have the value of 246. The rest will be 0. Okay. Now we want to print down those. How to do that? You will simply put f here, and that's it. Okay. During functional call, you only put the array identifier here. That will be sufficient. Let's say we want to write down, we want to modify that so that we print a desired element, like the ith element. Then we need to modify that. Okay, the prototype will be this, and then the integer, which is I. So that's the function print array prototype. And then here, during the call, I want to print the second element of that function. Then I will put 2 here, okay? Because that I later inside the function will be used to indicate the array index. Now let me write down the function, the print array function, the details of the function. Okay, here it will be void and then print array double x integer I. Here will be C out x I. Okay? There is only a single line that should be sufficient. What will happen is when you call the functional, when you call the array, okay, the array name will be passed here. So at that point, the program knows we are going to do something with this array. And these 2 will be passed as the integer I here. So inside the function, what it's going to do is to print out this particular element to the screen. Where f(x) is this x, will be now refers to the f array. So this becomes f, I is 2, therefore it's looking for the second element in this definition. This is the first, this is the second. So I should really write it as this, minus 1. If I indeed want to print out the second element. Why there is an offset of minus 1 here? Because the index starts with 0. Okay? So in this way, this number will be printed. The number 4 will be printed. Okay? Alright, let me highlight the important syntax here. This is the function prototype. And this is a declaration of an array. This is the calling statement of the function using an array as an argument. This is inside the detail of the function body. Okay? And the 2-dimensional arrays will be a little bit more complicated. So you need to read the text, okay, on that. All right, chapter 12 is about character sequence. It is important, but I would just like to point out that in C++, a character type is a real type. A string or a character sequence is a class, okay? And actually a string class is exactly an array of a character type. Okay? Think of that. Because array is used to store things of the same type sequentially. So when you define an array of a character type, char type, of size 10, for example, that array has the capability to store a word of length up to 9. The reason it's up to 9, not 10, is at the very end you need a termination character, which is backwards / 0. That is a terminating character. Okay, you always need that. Therefore, any character array with a null character, which is backwards / 0, is totally equivalent to a string type. Okay? Let me just write it here. let's say declare an array full of size 20. Then memory space of 20 will be assigned to that. Each cell can store one character, okay? All right. Then I can fill this value as like hello. We use red color and distinguish that. This will be called a character sequence. Okay? It has a number of characters. At the end, it has a noun character that terminates the sequence. Now, because of that, if you want to declare that and have this same value, you can do it like that. Character declaration full initialize to the value of H E L L O and now. Okay, this declaration not only declare full as an array of character type, it also initializes value to that. Now inside the memory, you will have that. And this type of declaration is totally equivalent to this character full 20 equals hello. Why these two are equivalent? Because this is a string class. It has exactly the same characters here. This one, when you declare that, you treat this as individual element. When you put it here, together with the noun character, it becomes a string. Okay, a string type. And this is just a string type. So these two are completely equivalent. Okay. But I like to also point out that when you do a declaration like that, this equal sign is not assignment, it's just initialization. Okay? If you declare this like this, and later you want to put these values here, you cannot do that. Let's say if you just declare that and without this, and then in the execution statement, you say, you try to initialize this value and then put it like this. This will not be allowed. Okay?